Hello. All right. Wow. They're okay. The faster they come back, the more I know that I don't know. Good to see you guys. Hello, Ashley. Hello, Sophia. Hello, Chloe. Hello, Stephen. Hello, Sarah. Hello, Jocelyn. Hello, Diana. Hello, Jamalet. Hello, Brooke. Hello, Jalen. Hello, Samuel. Okay, welcome back. I'm going to stay with you mentally here. Okay, we'll try to do it this way. Again, by the way, I don't know if it's clear. The sheet may seem out of nowhere. The whole topic might seem like it has nothing to do with anything we've done so far. It probably does seem that way. I will try to show you there really is a deep connection. Excuse me. All the material really does connect, and I will try to make that clear over the next couple of, okay, hold on. Let me see what. Oh, okay. Thank you, direct chat person. Public chat. Okay, fair enough. So someone in the direct chat just clarified that at least in part, at least one group was using the public chat, and that's why they were muted. That makes sense. That's fair. And I didn't mean to. Okay, good. Well, all right. Helpful. Thank you. Reassuring. So let me. Cool. I appreciate that. Okay. And that's another person in direct chat echoing that. Okay, cool. And I don't mean to be all shamey, blamey, or whatever. That is not a thing. It is now. No, okay. So I believe you, and that's good. And maybe I was the mere. Okay. Wait. Okay, cool. No, and thank you for the feedback. I'm seeing a lot of feedback now in the direct chat about what. So you're helping me, and you're even answering a question. So can I see electronic hands? Do you feel like? Can I see an electronic hand from everybody? If you feel like you if you got an answer even to number one, like to the first one, did you get? Oh, good. Okay. All right. We're making progress here. Okay. That's very good. We'll find out the answer in a minute, but great. And then now I'm going to skip. That's great. That's actually the most important thing. And it didn't seem like it was that stressful. Apparently I'm seeing from how, so now I'm going to jump. Well, let's keep going. Okay. Did you get an answer for number two? Hands up. We'll just do cool. That was fast. Cool. I'm seeing the hands. Okay. Keep your hands up if you got an answer for number three. Cool. And even if you hear me now, just like keep your hands up. I'm not looking at your names as such. I mean, I know you were in groups anyway. I'm just trying to get a sense. Number four. Did you get to number four? Hands are still up. That's good. Keep your hands up or put them up if you got up to put them up. If you got up to number four. Okay, that's a lot. That keep them up or put them up if you got to number four. Put them up or keep them up if you got to number five. There's still, so a lot of people finished, it looks like. Maybe not everybody, but a lot of people. That's great. It looks like. Am I right? A lot. Just to check here. Put your hands up or keep your hands up if you did anything. If you got any answers at all, put up your hands or keep your hands up. I mean, if you got any answers at all. If you got any answers at all, put your hand up and keep it up. Okay. Okay, I'm believing. All right, that's good enough for me. Okay, you can put your hands down now. Cool. All right. So I know we only have 18 minutes. I know this is a whole different concept, this whole thing. We're going to get to the concepts of it Monday and for the rest of the semester. Right now, we're just going to sort of do some of the math to get warmed up. So hold on 1 sec. So I'm turning this. Okay. Okay. And Q, we're going to do this very quickly. Remind me again, I'm about to get this wrong. The numbers. Q1 was 50 positive 50 coulombs. Is that correct? Can you confirm or deny in the chat? Q for the problem that you all just solved. The source charge, capital Q1 was it positive 50 coulombs? Is that yes? Great, thank you. Okay. And the R, the distance between the two charges was 5 meters, or could you confirm or deny in the chat? Was it 5 meters? Yes. Okay, great. Okay, and Q2 for, well, excuse me. All right, so hold on. So that was this is the setup. Oh, and KE is approximately 8.99 times 10 to the 9th newtons meters squared per Coulomb squared. Okay. Wait. Oh no, this is not a dumb question. Okay, no, I'm really glad. I mean, again, I'm doing an unusual thing by just like diving into this without explaining anything. I mean, but someone's asking in the direct chat a question that is not dumb. They're asking, can you explain the difference between the capital and the lowercase q's? I understand different charges, but the capitals has confused me. Totally great question. All right, let's go right with that. Okay, it's not a dumb question. Assuming, we just changed the view on the screen though. Well, no. Assuming this whole law is about what any one point of charge will automatically necessarily do to any and every other one point of charge in the universe. And I know you get that part, right? So the whole law assumes that you have a point charge, like some amount of charge, like shrunk to a very small volume, like maybe like a proton, or like maybe 3 protons like jammed together into a very small volume over here, and then some other charge, like maybe an electron or maybe 40,000 electrons shrunk to a very small volume over here, right? And I know you get that part. So Q1 and Q2, just in general, are referring to any 2 arbitrary point charges that you could have anywhere in the lab or the universe. And I know the person who's asking gets all that. But now here's the deal. Since it's any 2 arbitrary charges, and we're looking at the force that either one exerts on the other, since they're arbitrary, we assume probably, in all likelihood, they're 2 different charges. Like one is probably bigger than the other. Whichever one is bigger than the other, we call Q1. We call the bigger one Q1, and we call the smaller one Q2. And I think you probably got that. And then we tend to capitalize Q1, and we tend to lowercase Q2. So we tend, and we do this also with masses in the context of gravity, we tend to label the big charge with a capital Q sub 1, and we tend to label the small charge with lowercase q 2 to emphasize to ourselves which one is big and which one is small. It's for emphasis. It's just to remind us, here's the big one and here's the small one. But I'll tell you why. And as long as someone's asking this, please, everybody take notes on this. What ends up happening is, and you're going to see this when we do the exercises, the big one, Q1, we tend to then call the source charge, S-O-U-R-C-E, source. And we tend to call Q2, the smaller one, the test charge, okay? It is all just labeling, but it's, okay, no, you're not overthinking. It's actually an important thing. I'm glad you're asking, because what we're going to find out when we do these quick exercises, the fact is this equation is telling us the force that one charge exerts on the other. And the thing is, I'm talking to everybody now. Like, I'm glad this question was just raised because it helps us get into the material. The fact is that all forces obey Newton's third law, right? Anything I do to you, you necessarily do to me with the exact same magnitude, but in the opposite direction, right? And plus, multiplication is commutative. So these laws, this law that says F equals K Q1 times Q2 over R squared, the fact is it could be read either way. Whatever Q1 is doing to Q2, Q2 is also doing to Q1. But therefore, we have this labeling system that direct chat person is asking about. What we do is we tend to label the big one with a capital, because then what we do is we focus. Unless otherwise stated, we're always going to be talking about and focusing on the force that the big one exerts on the small one. Like, we'll know in the back of our mind that therefore also the small one is doing it back to the big one. But what we focus on is what the big one is doing to the small one. So we think of the big one as the source of the force, the one creating or generating the force. And we think of the small one as the one experiencing it. And that really, okay, so great question. And now that said, you'll notice that in this set of exercises that you just got with this problem, we keep the source fixed and we keep the distance fixed, but we keep in each exercise just trying out a different receiver for the force, a different smaller object. And that's in the way why we call that smaller object the test. Because we're in these exercises that we're about to get answers to, we're like testing the effect of this big guy on various little small guys. So yeah, that's why we tend to capitalize the big. Okay, I know I'm over talking, and I know he gets it. Yeah, that's the deal. The big one is regarded as the source. The small one is regarded as the test. So that said, we're going to jump into the numbers. No, that's really a great question. Diving into the numbers. All the numbers I just wrote on the board remain fixed, but then for exercise 1, we tested out a lowercase q that I believe, now you're gonna have to tell me, I believe, and please tell me in the chat, I believe we made it +3 coulombs, was that right? Yes, awesome, thank you, direct chat person. Okay, so for the first force, right, we're totally just plugging and chugging. We're just getting used to these numbers. And, if you remember the gravity equation from last semester, this is working just like the gravity equation, right? And it's just telling you the force that any one charge automatically exerts on any one other charge. And I always write this plus or minus to indicate that our answer, well, here, okay. I know I'm just going to do this quickly now. I'm not going to plug through all of them. You'll see why. And I know you did this. So, we plug in the 50. So we're saying the force that any one charge exerts on any other is it automatically happens. And it's directly proportional to the magnitude of the first charge. And it's directly proportional to the magnitude of the second charge. And it's inversely proportional to the square of the distance between the, and I left it. And then the whole thing is multiplied by this universal constant, this constant that you don't have to memorize, but you have to be aware that it's always the same. And in the case of electricity, it's a really big number. What's the deal with this constant? It's really there to make all the units work out. I'm doing this really sloppily, but you notice the constant is in units that look really obscure. Newtons times meters squared divided by Coulomb squared. But that's completely deliberate. It's to make the coulombs in the numerator cancel out and the meters in the denominator cancel out and make it so that everything you're left with at the end of the day is newtons, force units, because this whole thing is calculating a force. Now, when you also notice that as you know from chemistry, obviously, like the charge of from math that a positive times a positive equals a positive. So this whole answer I'm going to get when I multiply all the things together, I'm going to get a positive number, right? And I think the number, now you tell me in the chat. So, I believe the number we get, well, I know I could put the number in, you can put it in direct chat if you want, but can you I'll wait till I get 3 answers. I know we have 8 minutes left, but can I just see some answers in the direct chat for what you get when you multiply out all these numbers for exercise number 1. I know it's hard to write in scientific notation and all that, but we've 8 minutes. Can I please see in the direct? Oh, great. Oh, is that what you did? For some reason, I thought. Okay, keep going. Okay. That's one answer. Cool. I definitely agree with the exponent. Oh, wait. Okay, now I just got 2 different numbers. That's interesting. Can I get a couple more numbers in the... Great. And can I get one more number in the direct chat? Great. Great. Oh, wait. All right. I'm glad we're doing this. I'm getting some great things in the chat. Okay, hang on. I got a lot of numbers in the chat, and they were actually a lot of different numbers, but then I got some good questions in the chat too. Let me clarify one thing. I believe in these exercises, okay, and I know we only have 7 minutes. In these exercises, 1 through 5, what you're being asked to do right now is calculate the force that one charge is exerting on the other charge. And you're being asked to compute that force according to this equation that's given. You're being asked to just straight up plug into that equation. So I am asking for the force. One person in the chat said, wait, so we're solving for force, not field? Really good point. The punchline of all this, where this is all heading, is to try to explain to us and establish what we mean by field. But right now, I believe, unless I'm misremembering, in the exercises, it's just asking you to plug directly into the equation and get the force that one object is exerting on the other object. I mean, by object, I mean these points of charge. You know, what these are is like, what really it is like a bunch of protons squeezed together into a tiny space over here, and a bunch of protons squeezed into a tiny space, but fewer of them over here. We're just asking for force, number one. Now, number two, I get a question in the chat, a really good question. Someone asked in the chat, hold on, after you plug in those numbers, aren't you supposed to then multiply by R again? Okay, that's a really good question. It really is, because that's something that used to confuse me forever, and I'm sure it confuses many of you. The R at the end of the equation, the R, I'm going to write this, is an R with a hat on it, a caret on it. It's called R hat. What R hat, I mean, there's a slight sidebar, but R hat is the unit vector for R. It's defined always in physics. And I think we talked about this once earlier. I'll review it again, maybe on Monday. But for the record, the definition of R hat, I mean, R with a caret on top of it, is the vector R, the displacement R, divided by the magnitude of R. For any vector, vector with a hat on it means the whole vector itself divided by the length of the vector. What the heck does that mean? What's the point of that? If you take a vector and you divide by its own length, what you end up with is a vector of length 1 that points in a particular direction. R hat so the long and short of what I'm saying is, whenever you see a letter with a caret above it, that means it's a vector that points in the direction of R, but has a length of 1. So it doesn't change the numbers that you're doing. It's there to show direction. I'll explain this more on Monday, but that R hat is the direction of the displacement vector R, which points from the source charge to the test charge. I will explain that more on Monday again, but basically what I'm saying is it tells you to multiply the whole thing by R hat so that you can get a direction for the whole thing at the end. But you're really multiplying by the number 1. It's not going to change the numbers, but really good question. So what I believe, since I know we're about to run out of time, I got a lot of answers in the chat. Oh, thank you. Okay. I got a lot of answers in the chat. They're very different, so I am kind of glad we're going over this. I believe that the answer that I get or have gotten is this approximately. I mean, you could check again. And this is an answer that appeared a lot in the chat, but a lot of you got other answers too. And I know we've got 4 minutes left. Oh, and thank you all. Okay, again, that vector thing, I will review. I'm very glad someone asked about that. I will say more about it again on Monday. Please remind me anyway. But check your math. I think if you just literally plug in these numbers, you get something around 5.39 times 10 to the 10th, which is a huge number, right? It's a huge, newtons. You get this huge force because the constant that you multiply everything by is a huge number. Electricity, the electrical force that exists automatically between protons is a very, very powerful force. It's much stronger than gravity. In the gravity equation, the number capital G is a very tiny number. It's like 10 to the negative 11th. This one is 10. Okay, so this is much bigger. First of all, this is the answer I get. Maybe if you got a different answer, maybe put in the chat if this clarifies or if you see where you made your mistake or something. But I believe this is the answer. And yes, we're just plugging into an equation to get used to it. But now, with 3 minutes left, let me cut to the chase and say, I then ask you for the next 4. Oh, okay. I'm looking at the chat. Okay, fair enough. No, if you got, and remind me, please, all of you on Monday, R hat is very important. It's really simple once you get used to it. Like it never changes numbers at all. It just means one in a, but I like it threw me off the beam for years in college. Honestly, our hat really, it's worth talking about again on Monday. But so I'm totally with you if it, but it purely tells you direction. It's just the pure direction of R. But so if you get this number 5.39 times 10 to the 10th, right? Then for the rest of the exercises, on the one hand, the good news is, okay, you just plug in the same, just keep changing the value of Q2 and keep, where did the 50 come from? Oh, I believe 50, the 50 is the, I believe, someone's asking the direct chat, where did the 50 come from? Unless I'm wrong, I believe 50 was the given amount of charge of Q1. Like in every one of the exercises, you have a 50 Coulomb charge sitting over here, and it's 5 meters away from some other test charge, some receiving charge, and it's the test charge whose value we change in every exercise. Like in the first exercise, the test charge is +3, positive 3 coulombs, but each time in each exercise, the +3 is being pushed on by a positive 50. And person who's asking that direct chat, could you, okay, cool. So here, I know we only have 1 minute left, but I actually feel like maybe we're getting something done here because of all your questions. I mean, I feel like we're straightening something out. In all the rest of the exercises, the good news is you could literally just now that you get it, you could just like plug in and get the answers. But the reason I gave you those 5 exercises is actually I want you to see something. There's a faster way to do it. Once you get one answer, there's a faster way than to keep plugging in to the same equation. And in fact, since it's 1:30, I'll just leave it at that for the moment. You might want to just back up and think about, like, for the rest of, is there any trick you can do for the next 4 to make your life easier or not have to re-plug in every single time? That's the thing to think about. I'll leave it at that since it's 1:30. But thank you for being so indulgent and patient today. It feels like we did get something done, which is cool. You had 10 to the 9th. I think it's 10 to the 10th. You might have gotten 10.
No, I realized our decimal error, Professor. That's why we had a decimal off.
Oh, okay. So you're cool now? Like we're on the same page now?
Yes.
Okay, great. Okay, well then that's a great note to leave. So then everybody have a nice work on this. If you can, it's eventually due next, you get my point. I will work on your exams. I'm so sorry. Have a great rest of the week. Thank you. Thank you.
Have a great weekend.
Have a great weekend, Professor.
Thank you. Okay.
Before we leave, is the trick simply dividing by the charge and then multiplying by whatever the new charge is?